Okay, so today is trig identities, and we had an intro to them yesterday, but today is what I'm going to consider your first full day of trig identities and proving trig statements. So this trig statement right here, number 82, is on your class practice day one. I believe it's is it the 13th slide? Look on the little thing. You may have added some pages, but 13th slide? Okay, good. 13th slide of the 13.1 notes. All right. And this is a typical question, and you'll actually long for questions that are this easy soon, because honestly, this is incredibly easy. All right, but you don't have the tools yet to be able to do it. So I'm going to show you a bunch of facts that are true about trig. Now, we did a proof of exactly why all of these things are equal to each other yesterday, but I'm going to just boil it down here now for a quick review. Sine squared plus cosine squared, you might want to make a nice list of these, equals 1. It's a fact. And that means wherever you see sine squared plus cosine squared, you can replace it with a 1. But what's another fact that I can derive from the same exact statement? If I saw a cosine squared sitting somewhere, what could I replace cosine squared with? Would you agree if I rearrange this thing that cosine squared would be 1 minus sine squared? All I did is move this over to the other side and made it negative. Do you know you can do that? Another way to think of it is I subtracted sine squared from both sides. So do you get, if you had a cosine squared in the middle of a problem like this one, if there was a cosine squared in there, you could just, take it out, put in 1 minus sine squared. They're the same. They're equal. It's just like if I saw a 1/2 in a math problem, I can replace that with 0.5, can't I? Yeah, you're just taking it out and putting in something that's equal to it. If I had a 4 squared minus 3 in a problem, I could go, okay, 4 squared is 16, 16 minus 3 is 13. Couldn't I replace that with a 13? Yeah, you can do that because they're equal. So whenever you see a cosine squared in a problem, you can replace it with 1 minus sine squared. All right, what's another fact? Well, I gave you a couple others. Does anybody remember the snappy saying about the one with the tan? The one with the tan, notice it's squared, is what you seek. 1 plus tangent squared is equal to secant squared. So if I was in the middle of this problem, I'm going to make an imaginary one up here. Let's say this is the problem. Secant squared theta over 1 plus tangent squared theta is equal to 1. That's the thing I had to prove. If you get my first step, if this is the thing I'm trying to prove, my first step would be to take out something and put in something else that's equal to it, and then it'll make it a lot easier. In that green problem, I could remove the secant squared and put in what? 1 plus tangent squared. And do you get, then I'll have 1 plus tangent over 1 plus tangent, and those can cancel out and equal 1. All right. That's what a typical, what these are used for, is doing proofs. All right, so next step, you need one more for your list. Make a nice, clean list. Label it Trig Identities. If you haven't named your file yet, name it Trig Identities. You want a nice, complete list of these puppies. I'm not going to give you every single one today. I'm going to give you all the ones that you'd need to do today's proofs. All right, what was that next little saying? Did I get to the next one? I think we ended pretty quickly after this, but did I get to the one about a coat? The one with the coat, it's a funny looking one. The one with the coat is cozy, yes. And that's cosecant, cosecant. It's kind of like pilot and copilot. You got tangent, you got cotangent. You got secant, you got cosecant. Yes, I got stuck on this. I got my numbers confused, but I'm not confused anymore. The people at home can't see this, so I'm just going to pause for a second. From these three, they're called Pythagorean because they're all based on sine squared, or a squared plus b squared equals c squared. I can get so many different things. Like, would you agree I could take a 1 that I find in a problem and replace it with sine squared plus cosine squared? That makes sense? Okay, but I could also take a 1 in a problem and replace it with what? Secant squared minus tangent squared. What just happened there? If you move this to the other side, it'll be minus tangent squared. Secant squared minus tangent squared is also equal to 1. Or I could see a 1 in a problem and replace it with, not cosine, cosecant squared, this one. So I'm going to say this one, if I got it alone, would be, move this over to the other side, cosecant squared minus cotangent squared. All right, what if I see a cotangent squared in a problem? Cotangent squared. Would you please write down what you think it's equal to and turn it and show it to the person sitting rows 1 and 2 compare, rows 3 and 4 compare, rows 5 and 6 compare. Just write it down. This, I think what he just said is, did I say cotangent squared? If you see cotangent squared in a problem, what could you replace it with? Cotangent squared would be what? Cotangent squared equals what? Well, basically what you're telling me, Mr. Server, is to solve for cotangent squared. So I can just subtract 1 from both sides. Yep, you're right. Cosecant squared minus 1. Raise your hand if you had that one right. Okay, good. Then, if you can factor it, you should. Okay, cosecant squared minus 1 is a lot like x squared minus 1. And that can be factored into x plus 1 and x minus 1. So what do you think cosecant squared minus 1 could be factored into? Cosecant minus 1 could be factored into what? Cosecant minus 1 or plus 1 and cosecant minus 1. That's another thing that cotangent could be replaced with, is all that. Holy smokes. All it is factoring. All right. I didn't say just cotangent, cotangent squared. You could be right, but I was asking you about cotangent squared. Oh, can you square root these things? Yes, just like you can square root x squared. But do you remember if I have x squared equals 16 and I square root both sides, the answer is not just x equals 4. It's absolute value of x. All right. You need that? Oh, that's sorry. Yeah, forget it. All right. Just didn't know what you were holding there. All right, so I'm going to move on to cotangent squared. Could be broken up into cotangent times cotangent. They're the same exact thing. Cotangent squared is just cotangent times cotangent. True of all of these. So cosecant is just cosecant. Sorry, this part, cosecant squared, is just cosecant times cosecant. That's what squared means, times itself. All right, so if you were in the middle of this problem, I have, let me think, secant squared theta over 1 plus tangent squared theta all, let me think, And then I'm going to put a sine squared theta here and a cosine squared theta here. And then I'm going to put a, just to make your life just a little easier, I'm going to put a plus 1 here. That's a really complicated looking question. You watched me construct it. Anybody know what the answer is? 1. That's equal to 1. So what if your proof was it equals 1, prove it? You can't just say, well, it does. You have to prove it. So how do you prove something? You prove something, now this is important, it's not an equation where you can just multiply both sides by something or add something to both sides. You can never touch one of the sides. You have to pick, and you can actually change your mind and restart the problem if you want to. But you have to pick and either say, I'm going to take the left side and adjust it and make it equal the right side, or I'm going to take the right side and adjust it. But one of the two sides you have to not touch. I'm going to personally choose to not touch the 1, and I'm going to say equals 1, equals 1, equals 1. And now the left side, I'm going to make some substitutions. So, tell me something I could swap out. Yes, sir. That was all equal to 1. Right? We know it's true. Got a list of these things somewhere. So if that's all equal to 1, I'm going to rewrite this problem with a 1 up there. 1 plus secant squared theta. All over the denominator I never even touched. 1 plus tangent squared theta plus 1. Okay, who can make another change? Mr. GC. I'm going to replace secant squared with, I'm going to go up to my list here. Secant squared is, oh, there it is, 1 plus tangent squared. Okay, so I'm going to replace that with 1 plus tangent squared. Wait a minute. That's pretty much the same thing on the top and the bottom, isn't it? So then I can say, notice me not changing the right-hand side at all. It still equals 1 over there. The left-hand side simplifies to 1 over 1 because they're the exact same thing. I could probably clean it up by saying 1 plus the 1 makes 2, and this 1 plus 1 makes 2. But they then will look exactly identical to each other. And so they can cancel and equal 1. And 1 equals 1. Notice the end of a proof is the exact statement of two things being identical to each other. Here's a common mistake. Somebody gets done with the proof and they get down to this last step and they say, so 1 over 1 equals 1. That is not proven. You've got to take the very last step and make them identical. So therefore 1 equals 1. That's an okay way to end. A proof has to end with a exact equal on both sides. Not just something that could be equal if I made one more tweak. All right, so now let's go back. Oh wait, there's one more thing. Remember that list I was giving you? I'm going to undo all this writing I've done. And this list I was giving you is of all the important identities, and you labeled it Trig Identities. All right, I'm going to give you another set. These are important. They're the flippin' sisters of each other. I think you'll understand why I call them the flippin' sisters. Sine, cosine, and tangent. I've known these for a long time, haven't you? And normally we said sine of theta is opposite of right hypotenuse. But that's when you're in a triangle. This is when we're doing trig identities. I'm going to say sine is the same as in wherever I see sine, I can put in this. 1 over its flippin' sister. Anybody know which one goes with sine? Cosecant. And cosine is the same as its flippin' sister. Cosine is 1 over a said it was the same as. I should say it's the same as 1 over its flippant sister. Cosine goes with secant. And the last one are the only two that kind of make sense to me. Tangent kind of logically goes with cotangent. So how are you supposed to remember these? I'm going to just point out that you knew these before, right? So the ones that are new to you are these green ones. Tangent and cotangent sound like they go together, don't they? And the other ones, an S goes with a C, and a C goes with an S. SCCS. Tangent goes with cotangent. Memorize these however you'd like. We're going to be doing them a lot, so you're probably just going to get used to it. But when you see something like this problem right here, you will need those factoids. Who can tell me something I could swap out? I'm going to leave the right side equal to 1 the whole way. What could I swap out on the left side? Yes, ma'am. Cosine is 1 over secant. Notice me drawing a little arrow to it. I want you to do that. When you make a swap, I want you to show me what you swapped by drawing a little arrow like that. It really helps whoever's following your proof understand what happened. And then normal rules of math apply. Like for instance, if I have secant, that's the same as secant over 1. And if this is a multiply problem, or if there's an empty spot between them, that indicates multiply just like before. So that means time, so I'm going to put in a dot here. And now do you get why it equals 1? Can't I just leave it like that? No, I have to simplify it again. And I can go like this if I want to, cancel, cancel, but I'd have to simplify it to 1 over 1, and then do the final simplification. It's identical on both sides. There we go. That was a simple proof, and like I said, you'll long for the days when they were that simple. Because within a week or so, you're going to get up to ones that are like, whoa, you have to do like 9 steps before you get to the answer. Yes, sir.
How do people use it in the real world?
This is more about teaching you how to prove something. Your boss doesn't come up to you and say, you know what, I got to prove that cosine over sine squared is equal to cosecant times cotangent. But by showing a logical step proof, in the real world, you do have to prove things all the time. Like you might be an engineer that's being asked to prove that this is not going to do damage to the ecology of the site upon which you're going to build. And you can't just say, well, see, it's because of this and this. You have to build a logical proof, one step at a time, and say, first of all, we know that this is true. Second of all, we know that this is true. Now we can prove that since this is no worse than that, I've proven this. And you be logical, one step at a time, proving things to somebody. You might relate to this. It's kind of difficult to prove things to people because they get stuck in their mind that their way is right or whatever. So this is more about a thinking process than you aren't going to have your boss walk up to you and say, prove this. I will tell you one more time you're going to have it. If you go to either HL or AP Calc, the next year you're probably going to take the AP Calc test. Upon the AP Calc test, there are proofs just like this. Okay, so that's another time in your life that you're going to need it. All right. So next step. Number 88. Do you remember me saying that you got to keep one of the two sides, like leave it alone? In my opinion, it's easier to leave the left side of this one alone and adjust the right side. Keep tweaking the right side until it finally equals this left side. And it's okay with me if you want to put hash marks like this or ditto marks to mean I'm keeping it the same, I'm keeping it the same. But at the very last statement, you'd have to say cosine theta over sine squared theta equals, and this better have come out to be exactly the same. So I know at the end, it's going to look like this. This one's a little tougher. It's not impossible. Anybody see the path already? All right, I'm going to give you a moment. This says a 5-minute question. I bet you some of you will get it after 1 minute, honestly. Take the right side. Make some swaps. There's one more that I need to remind you of before you do this proof. So back to your sheet. I could tell there was, since nobody got it already, there's usually something missing. So these flippin' sisters has one more little thing. You already knew it. I shouldn't have to tell you, but I get how you knew it in a different context. What is tangent? Sine over cosine. Very good. So tangent is not only equal to 1 over cotangent. I'm going to go the other way with it and say tangent is also equal to sine over cosine. Then logically, what's cotangent equal to? If tangent sine over cosine, and cotangent is a flip of tangent, what's cotangent have to be equal to? Cosine over sine. And I hope you get that logically these others follow. I don't want to have to make you write this list, but if you saw this, cosecant, logically, if sine is 1 over cosecant, what is cosecant? 1 over sine. And if cosine is 1 over secant, what is secant? One over cosine. Maybe you should write these, and they're not flowing for you super easily. If tangent is 1 over cotangent, then what's cotangent? 1 over tangent. All right, so take a look at this one again. I suggested you tweak the right side and leave the left side alone. Somebody's going to get it. Somebody's going to get it pretty quick. But I want all of you to get it, so that's going to take a little bit. I'm going to pause for a minute. I'm going to give this one a shot. So when you see the answer for this, you're going to go, oh my gosh, that's so easy. This is one of those times where when you see the answer, it just seems like, oh, these problems are so easy. I'm going to be fine on this test. Because I'm looking at the problem, I'm looking at the answer, and when you see the answer, of course it's easy. Really, these are like worse than normal, where you see it and you go, oh, so easy. But yet, 3/4 of you are stumped right now. So they aren't that easy, but they seem like it when you see the answer. All right, so who's got a thing I could replace here on the right-hand side, and what would you replace it with? Yes, ma'am. All right, so I'm going to draw a little arrow. And this is 1 over sine. And then leave the other one alone. Cotangent. Okay? Why don't you tell me where you're headed next? Because you can go different directions with this. But. Oh. Cotangent. I'm not going to erase it. I'm going to draw an arrow and say, okay, now I'm going to leave this side alone. 1 over sine theta times, what did you say it was again? Cosine over sine. You see that I'm pretty much there. What was I trying to make it equal to? That. And on the top, don't I have cosine? And on the bottom, don't I have sine squared? That's it. That's all there was to it. You had to make this little swap where cosecant became this. And you had to make this little swap where cotangent became cosine over sine. I know that's the one that probably stumped a lot of people. Maybe you didn't even think about how sine times sine would end up making sine squared, just like we wanted. All right, let's do another one like that. out of your homework? I'm considering this like day one. Because although we talked about it yesterday, we really didn't actually do any problems. This is your first of your homework questions. Even though it's a little bit different to be doing one in class, I think in this case, I'd like to walk through your first one with you in class. So we're supposed to prove this thing is true. I would either tweak the left or the right side, and from my experience, usually way easier to take the more complicated side and break it up and flip it around and everything and leave this cosecant alone. Usually it's best to just make this the same all the way down and tweak the left side. So when I see a cosine squared, I think to myself, where on my list of formulas is there a cosine squared? And you write down that one. What's that one you just said? Sine squared, what? Plus cosine squared, theta equals. That's the fact that we know. Now I look at it and I go, okay, 1 minus, oh yeah, 1 minus cosine is equal to something. What is 1 minus cosine? Because see, 1 minus cosine is if I put this cosine to the other side, I'll have sine squared is equal to 1 minus cosine squared. Cool. So I can replace this right here with sine squared. So what would I write? On my right-hand side, I'd leave the top alone. And I'd draw a little arrow to say what I changed. I changed that into sine squared. Next, do you remember that sine squared can be broken into two parts? Sine squared is really sine times sine. We did that in our last proof, right? So I'm leaving the top alone. And on the bottom, I'm getting sine times sine. And that's just begging me to cancel those off. So I will. Doink, doink. Replace it with a 1. And 1 over sine squared is equal to what? Cosecant. And that's the moment. That's it. Equals, this whole time I was trying to make it cosecant. There we go. All right. So your homework is to do all of day ones and memorize all of the ones that I gave you today. So tomorrow I should be able to say cosine squared, and you should be able to go 1 minus sine squared. I should be able to say the one with the coat is what? Cosecant squared. I should be able to say the one with tan is secant. And what instead if I said secant minus 1? That would be tangent. If you have to, you just write the original statement down and then figure out how you could morph it. Okay. Hint. Also, sometimes you have to be able to factor things like that. I hope this doesn't make your brain explode. But if this was as simple as x squared minus 16, do you remember how to factor that? It's two perfect things, perfect squares, and they're subtracted. It's called difference of squares. X plus 4, x minus 4. Remember that? Okay, so what in the heck is cosecant squared minus 1? Okay, hold on. Cosecant squared minus 1 breaks into CSC minus 1 and CSC plus 1. Cosecant squared breaks into cosecant minus 1 and cosecant plus 1. Sir. Now, just to clarify, Do I have to factor it? No, but it's one of those things you can do. What's the fact we know about cosecant? The one with the code is cozy, right? So I'm going to take this and go, okay, well, I know there's something to do with that. So I'm going to write that original statement down, that thing I know about cosecant. I'm going to go, one with the code is cozy. There's my fact. Can I rearrange that and say, move the 1 over to the other side? And say minus 1 over here? And say cotangent is cosecant squared minus 1? Yeah. And so cosecant squared minus 1 is probably going to be cotangent. So you probably should just put cotangent right there. But do I know for sure? No. I just wanted to show you that little deal where you can factor it, because sometimes that's the secret sauce. It's being able to factor stuff. Let me give you another example of like a crazy thing that you can do. 1 plus tangent. Would you agree I can replace the 1 with what? A whole lot of things. Sine squared plus cosine squared, yep. Or cosine squared plus sine squared. Reverse it, either way is fine. I could replace the 1 with, well, I know a whole bunch of statements. The 1 with the code is cozy. 1 with the code is cozy. I could solve it for the 1 and figure out what to put in for that. All right, how about this one though? This is the one I like. If tangent is sine over cosine, do you get why the original problem of 1 plus tangent could be made into this pretty quickly and easily by just making that little swap? Then here's a little outside the box one. This 1 right here, what could you replace it with? That would kind of work nice with this. Instead of 1, I could put cosine over cosine. Very good. Why is that smart? Because now they have a common denominator, and now I could actually add them. So my original problem might have been take 1 plus tangent and prove that it's equal to cosine plus sine over cosine. And I'm almost done. Because now that I got a common denominator here, I can add the tops and leave the bottom the same, and I'm pretty much going to have this. All right. There's a few tricks like common denominators, like making a 1 into anything over the top of itself, anything that makes it handier for you. Making a 1 into sine squared plus cosine squared. All right, this is the part where trig gets real. So are you going to like step up your effort level to meet it and therefore keep your A that many of you have going in this class? Or are you going to keep the same effort level going, and as the material gets a lot harder, your grade slips? That's the choice you face, because this isn't easy. And you know this next few days is going to stretch you. So you have to make that decision. I'm fine with either one. I'd prefer it if you would step up your effort and hang with it and handle it. But some people will drop out at this point and go, I don't get this at all. And you'll be stuck with D's for a while. I don't want that to be anybody, but just want to warn you. If you decide to like, well, I didn't really do my homework last night, during this unit, holy cow, you're going to be lost really quick. So keep up with your stuff. All right. The easiest trig stuff is over. This isn't impossible. Many of you are still going to get A's in this text test, but it's going to be more confusing in the meantime. So stay with me. All right. That's all I got for you for today. Your homework is to do the entire assignment from day 1 and make sure it's done by tomorrow.